Morning, everybody. We are on session 18 out of 32 sessions that we're going to be going through. Today's session is about water requirements. Every shelter has to have some type of system, usually a pressure system. There's a lot of people out there who do these caveman shelters where they've got 5-gallon buckets and they dip their bucket in, and they've got a 5-gallon bucket for a toilet and so on. But that's not the kind of shelters I design. If you want the caveman shelter, this is not the session for you. So this is how we normally do it. To me, to have a long-term shelter, you need a shower, you need some type of sewage lift station, water filtration, pumping, and a pump here, and some type of distribution system, whether you use a tank or a well. But what are the actual requirements for water? The actual requirements is based on temperature, and normal use would be on this curve here. So this is survival requirements, and this is a little bit above. I usually try and get at least this if you're using a tank. So you want at least a gallon a day per person, and I'd like to double that. If you can survive on that and do well on that, but if you want to shower and cook and so on, you really need about 8 quarts, 2 gallons a day. So when I design tanks for a shelter, this is the curve that I use. So 2 gallons a day per person for 180 days, 365 days. That's what you want to size it for. And here's where a lot of people run into trouble. Because water tanks are so big, and you don't want them in the shelter. They just take up too much room. It's much cheaper to get a fiberglass tank that you can put outside. And remember that when you put a fiberglass or any tank in the ground, 75% of this diameter minimum has to be above this to keep it in the ground. But where we usually run into trouble with this is a fill pipe at the ground level. You do not want to have a vent here. When the water goes down, it's going to draw air from somewhere. You want it drawing in from the shelter. So you've got water supply coming in. As you're taking water out of here, the air is going back to the tank, and it's the filtered air from the shelter. You don't want the air from outside going back into this tank, because then you're taking in chemical, biological agents, dust, and everything else. So that's one of the mistakes that I see a lot of people making. You need a fill with a non-venting cap, usually a fiberglass tank, and you've got a supply on one. So this one would go down to the bottom of the tank. This is the return. The air would come up and go to the top of the tank. You never ever put fittings at the bottom of a tank. And the next thing is when you set up kitchens and water filtration, whether it's 12 volt, 24 volt, or AC, you want to put the water filter, and you want to get the right water filter. That's a trick. This water pump, usually I use a marine pump or a submersible pump for a well. This has a pre-filter in it. You can get all kinds of pre-filters depending on your starting water quality. And this has to be on the positive side. You need pressure to go through here. This is a really good water filter. It's a triple stage, and it takes about 20 psi to go through here and produce about 2 to 3 gallons a minute. But this is the way that we normally use it. These are the normal tanks. There are problems with both. This one is a nightmare because over time this creeps. This is designed to resist hydrostatic pressure, and it actually does that. The problem is because the plastic, the E value, the strength of material, is so low. It's about 100,000 psi. Wood is about 1 million, fiberglass is about 6 million, and steel is about 29 million, just to give you a reference point. So this creeps. So you may start off with 1,000 gallons, but you're going to have about 700 gallons after a year. So I wouldn't recommend this. This is a whole lot better. This is designed for 3 feet above the top of this. You have to put necks on here. This is a much better tank. I don't like either of them actually, and I usually don't use either of them. I usually use a round fiberglass tank that's designed so you have enough earth over the top, and it'll withstand the overpressure as it comes across. Although the overpressure is very quick, and there's some earth arching that would probably go around this one. It won't go around this one, but it would probably go around this one. You might be okay, but in military corporate shelters, I can't gamble on might be okay. So the best thing to do is to get maybe a 500 or 1,000 gallon fiberglass tank that's designed to be underground, plus the overpressure of the tank, because this is all criticality of one, so it has to work. You can chlorinate the water. This is how I usually chlorinate the water. This is in POP. There's a formula in there, and you want to be careful that you get sodium hypochlorite. The stuff you buy from the store sometimes has some other additives in there which you don't want. But if you buy pure sodium hypochlorite, 8%, 15%, whatever it is, 6% is common now since COVID's been out, and you can use that. But there's a formula in the book. It'll tell you how to mix this. You really can't over chlorinate it. Chlorine doesn't stay in the water. It actually goes in the water and outgasses. That's why you have to re-chlorinate pools every day. So it's pretty hard to overdo it. And whatever's left, the water filter will remove most of that. But good water filter is at 99.99%. The problem in the industry is that they say that if a manufacturer claims it's filtering typhoid, it's filtering mercury and lead, it has to tell you at what percentage it's doing that. So because something says it'll filter E. coli, does it filter 99.99% of E. coli? So you got to read those labels very, very carefully. And what you have to do is go to the EPA filing and look at the EPA filing and see what it actually claims versus what it actually does. So it means you have to do a little bit of homework. But that's how you have to do this. Even if you have well water,